Thank you for having me. So I'm Chen from IBM Research. Today I'm going to present you to a new unified framework called Computational Safety for Generative AI. And the reason I want to do that is I want to introduce to you a new existing method that is very useful to deal with these computational safety challenges that existed for decades, but kind of being overlooked under the radar in the context of safety. And the interesting part and challenge of the doing safety and alignment is that if you ask any random audience from this workshop, like what do you mean by safety or alignment, or what do you care most about the most challenging problems, you will get very different answers. But nonetheless, right, this computational safety, I think hopefully by formulating it in a unified framework, right, we can solve it using a very powerful asset through signal processing. Okay, so what do I mean by AI safety? This my version of AI safety is we are really is a research that studies the operational risks and challenges associated with social and technology robustness. And most of the time, we spend our efforts in understanding the possible and potential harm and risks of frontier AI models, right? So we evaluate those harms, right, and prevent those harms before they actually being deployed to the public. Right, but there is a gap, right, between development and deployment. Right? When we develop AI, we always assume everything is ideal, IID, nothing. No one tries to break our model. But in reality, when we start to deploy this AI system, that we start to see those challenges that we are facing, which is what AI safety is aiming to address. Okay, so based on that, right, my definition of this framework called computational AI safety is a set of safety problems that can be formulated as a hypothesis testing problems. It's a very well-known problem in signal processing. And the most simplest form of hypothesis testing will be binary hypothesis testing, right? You're having two hypotheses, H1, H0, and you want to detect, based on the statistics you observe, which one is true. But what is new in this generative AI world is that hypothesis testing in this context cannot be predefined, right? So in the classical setting, when people use hypothesis testing, we are either testing, okay, are the two distributions we are observing, are they the same or not? Or is there a mean shift or variance shift compared to a reference distribution, right? But in this case, right, since we are dealing with safety, right, so many of times, right, this ground truth answers, if you may say that, depend on the context, right, depending on how the model is being deployed, depending on where the user is in which region is using those language models, right? So this hypothesis testing basically have infinite possible ways of hypotheses that can be generated depending on what input you give to the model and what output you receive from the model, right? So it is very difficult to predefine mathematically and precisely, and that's why a lot of hypothesis testing problems in this space for safety is defined through this language model as a judge techniques. So some examples of what do I mean by computational AI safety, right? It's actually very straightforward now if you think about this in a unified framework, right? Like jailbreaking prompt, right? Given the prompt, can we detect does the prompt has a malicious intent to jailbreak or not, right? Given a data sample, can we detect whether that sample is AI generated or a real image, right? Given a possible model update to the model through LoRa or full fine tuning, can we detect whether that model update will break AI alignment or not, right? Given the sample, right, can we say, okay, this this sample has a watermark or not, right? Or given a model, right, can we do some inference to see are there any training sample being used in this model related to unlearning, or has this model been trained on a specific data set for data set contamination and things like that. So many of these things, right, can be formulated and boiled down to this concept of some sort of hypothesis testing problem. But the challenge here is how to integrate that with a language model as a judge to reliably carry out this test and detection. And if we can do that, we can certainly build a better safety guardrail. I have a few minutes left, so I want to seconds left. So I want to use this to summarize what we did and some successful examples we explore in this space, right? So if you look at the landscape of language model, right, there's input, there's a model itself, and the output that model generates. In the input space, we already found that signal processing tools are very useful in terms of detecting jailbreaking prompts, right? So if you look at the sensitivity of those prompts in the embedding space after perturbation, jailbreaking prompts will show higher sensitivity than normal, like harmless prompts, and therefore you can use this sensitivity to build a very effective detector to capture those prompts with jailbreaking attempts. For the model itself, right, when you want to update your model, you can also detect whether that model update will compromise safety or not. Similarly, for the model output, you can detect a sample will contain the deepfake or harmful content or not using sensitivity analysis. So if I do my alignment right, I hope I will call my alignment successful if you are able to check the paper associated with this talk. With that, I will end my talk. Thank you.